Hello students, today uh, we will embark on an exciting journey into the world of physics. We will explore the intriguing concept of gravitation, a fundamental force that governs our universe. We will unravel the mysteries of how objects move under gravity and why our weight changes from place to place. Lastly, we will dive into the conditions that allow objects to float in liquids. And the content is taken and covering this content is covering the chapter 9 of CBSE syllabus and chapter 10 of Karnataka state syllabus. I'm exactly following the NCERT, the content provided from the school books. uh, the index, this chapter, the gravitation contains mainly 6 topics, which are gravitation, free fall, mass, weight, thrust and pressure, Archimedes principles. Now, let's recall what we learned from our previous classes. Okay, we learned that objects move and force is the cause of motion, right? A force is needed to change the speed or the direction of the motion of the object. An object dropped from height falls towards the earth. All the planets go around the sun. The moon goes around the earth. There must be, see, everybody is moving, right? So there must be some force acting on these objects, the planets, the moon. So Isaac Newton, he was able to grasp that some force is responsible for all of these. And this force is called gravitational force. In this chapter, uh, let's learn about gravitation and the universal law of gravitation. For all the reasons, in this video, this topic will be our focus. Okay, as a next videos, we will be also discussing the motion of objects under the influence of gravitational force on the earth, and we are going to study how the weight of a body varies from place to place, and we are also going to discuss conditions for objects to float in liquids. Now, let's try to explore, what was Newton's insight about the gravitational force. We know that moon orbits the sun. Objects thrown upwards fall back down towards Earth, right? So Newton's apple incident led to a revolution to him, right? So you know the story, right? He was sitting on a tree, sitting under a tree, and apple fell on his head, and he started thinking why apple fell down instead going up. So and this incident led to a revelation. What was that revelation? Okay, he questioned if the Earth's attraction to an apple is similar to the moon, because apple fell down because it got attracted by the Earth. Is it same thing happens for the moon? Is it moon is also getting attracted by the Earth? He started questioning himself, thinking about it, right? He hypothesized that the same force is at a play in both the scenarios. The force which is happening, which is there between apple and Earth, it must be the same force between moon and the Earth. He hypothesized. So he argued that at each point of its orbit, moon's orbit, at each point of moon's orbit, the moon falls towards the Earth instead of going off in a straight line. So it must be attracted to the Earth. Okay. But his claim is that okay, the moon must be at each point of its orbit, moon must be falling towards the Earth. But this falling is not visually apparent to us. It means it's falling, but it's not apparent to us, visible to us, right? What's happening here? These are the couple of thoughts triggered, insights provided by Newton. Now let's do a small activity. Take a piece of thread, a piece of thread. Lay a small stone at one end. Hold the other end of the thread and whirl it around as shown in the figure. Note the motion of the stone. Note the motion of the motion. It is circular, remember. Okay. You can clearly see it. Then, as a second part, release the thread. Again, note the direction of the motion of the stone. Okay, let's see. Let's observe. Let's see what happens. Let's go for observations. Before the thread is, released, stone moves in a circular path with a certain speed and changes its direction at every point. See, it's circular. It has to keep changing the direction at every point. Okay, and the change in the direction involves change in the velocity or acceleration. The same point, right? The change in direction, because it's changing the direction, it's changing the velocity or acceleration. Okay, the force that causes this acceleration and keeps the body moving along the circular path acting towards the center, right? Because some force is acting toward the center, or which is keeping this object along the circular path, moving and on the circular path, along the circular path, right? This force is called centripetal force. It means it's center seeking. This force is, center seeking force. So generally we call it a centripetal force. In the absence of this force, in the absence of force means, assume for a moment you left the thread, that stone moves in the direction, a straight line, right? In the absence of this force, the stone flies off along a straight line. A straight line, you can see that, right? This is the straight line. Okay, the this straight line will be a tangent to the circular path. Okay, the circular path, earlier it was circular path, but now the in the absence of centripetal force, this stone moves in a straight line, and this straight line is tangent to the circular path. Okay, then let's understand what is this tangent. By definition, right? Tangent is a line which touches the circle at exactly one point. So in this case, you can relate both the activities. Correct. Now we got some slight introduction insights, about centripetal force. Let's deep dive. Okay. Let's take an example of the moon's motion. The moon orbits the Earth. Why? Because of centripetal force. What is centripetal force? It is a center-seeking force. I mean, what is center-seeking? Earth is a center here, right? So, which is Earth's gravitational force? In this case, Earth's gravitational force is a centripetal force acting on the moon. Okay, and this is what is causing the moon to orbit around the Earth, Okay, yeah, imagine for a moment Earth has no gravity. What happens to the moon? Does it still continue to orbit the Earth? No. Okay, the moon would move. The moon would move in a straight line. For example, this way. It keeps. Assume you lose the contraction when it's rotating like this, and Earth loses its control, and then it starts moving this direction. Okay, something you should be careful. I mean, you should try to understand. Uh, okay. Let's take one more topic. Go back to the apples, the attraction. Since we know that, right? Apple fell, and apple fell because it got attracted by the earth. Does it mean, since we know that earth attracted the apple, so it fell down, right? Does it also mean that apple attracts earth? Let's now understand, let's go deep dive, let's think about it. Hmm? Earth's movement, right? The earth is attracted to the apple. Yes, the answer to the previous question is yes. The way the apple attracted to the earth is also getting attracted to the apple because it's a mutual, the Newton's law, right? But we don't see the earth moving towards the apple, whereas I see apple moving towards the earth. But we don't see earth moving towards the apple. Why? We need to understand that. We'll cover it up in the next slides. Okay. Let's continue with centripetal force. Let's further, right? So we know Newton's third law, right? What is the Newton's third law? According to the Newton's third law, apple and earth attract each other. It's not just earth attracting the apple. Apple also attracts the earth. Remember that. It's a mutual. What then? How do we understand? How do you conclude? By Newton's third law. What is this Newton's third law? See that. Every action in nature, there's an equal and opposite reaction. In this case, what is action? Action is a force. What is it? Earth is attracting the apple. And as a law of nature, okay, there is an equal and opposite reaction from the apple, which is apple also attracts the earth. Okay, and this force of attraction is equal, okay, but in opposite direction. Okay, so one side is earth attracting, other side is apple attracting, but the amount of force is magnitude of force is same in both the cases, right? Now let's take why question. But you see, we saw them, right? Both attract each other, but we don't see earth moving, we only see apple moving. Why is happening? Let's try to understand that part. Okay, to understand, let's take a Newton's second law. What is Newton's second law? Force is equal to mass into acceleration. Okay, now what we concluded now, the magnitude of force by the earth is same as the magnitude of force or magnitude of attraction from the apple. Both are equal. So F should be equal in both the cases. Okay, but why they're not moving? One is moving, one is not moving. Okay, let's see. So let's now compare the mass now. Okay, so now look at it. What is force? Force is equal to ma, right? This is earth. Let me call it as earth here. Is equal to, let me call it as apple here. Mass. Why I'm equating? Because force is same in both the direction. Both the direction is different, but magnitude is same force, right? Now, so m1 a1 is equal to m2 a2. Very clear, right? So now let's understand why only apple is moving. Why not earth? Okay. Let's compare the masses here now. See here a mass of earth, mass of, okay. The mass of earth is very, very, very high compared to the mass of the apple. It means I can say mass of the apple is negligible compared to the mass of the earth. Now, this product term should be equal by definition because force is equal. How this equality can be maintained? By this acceleration, this has to be very, very negligible compared to this, right? So that is why, since mass of this apple is very, very, very small, to maintain this equality, acceleration of apple will be very, very, very high. That's how we see apple moving, but not force. Sorry, but not earth. Okay. Result: we don't see the earth move towards the apple due to its much larger mass. We learned it, right? Because it has got a higher mass, and of course it has got a very less acceleration. Apple has got a less mass, it has got a very high acceleration. That's what we can conclude why apple is moving and earth is not moving. This is one of the topic, right? Let's go to some other next topic. Right. All right. Now, other topic. Okay. Earth and the moon. The same argument applies to why Earth doesn't move towards the moon. Why Earth doesn't move towards the moon. You understood, right? Because why Earth doesn't move? Only the moon is moving, not the Earth. Why? Why? The reason is the mass of Earth is very high compared to the mass of the moon. Naturally, the acceleration of the moon will be very, very high compared to the acceleration of the Earth. Okay, whichever has a higher acceleration, they move, and in this case, moon moves. Okay, in the solar system also, all planets orbit the sun due to the force between them. But which moves? Planets moves compared, and sun doesn't move. I mean, sun also moves, but not with respect to the planets. The reason is the mass of sun is very, very high. Naturally, its acceleration is lesser. So what Newton concluded out of all these things, right? All objects in the universe attract each other. All objects in the universe attract each other. Okay, and this universal attraction or the force of attraction between objects, and this is called as gravitational force or simply gravity. Okay, so this is how Newton was able to conclude that all objects in the universe attract each other, and this universal attraction he called it as gravitational force, or in simple word, gravity. Now this is for your exam. You should be able to exactly reproduce in your exams. Okay, let's understand what this universal law of gravitation, uh, mentions. Okay, before that, let's take two objects, A and B. A has got a mass, of course, B has got a mass. Let's call mass of A as capital M, the mass of B as capital B, sorry, small b, small m. Okay, and let's assume D is the distance between the two objects. It means center to center distance between the two objects. Now let's go for the law. What it says, right? It quotes every object in the universe. It means every object in the universe attracts every other object. Okay, with a force which is proportional to the product of their masses and inversely proportional to the square of the distances between them. It is simple, right? Every object attracts every other object. Universal law quotes that every object in the universe attracts every other object. With what? With a force which is directly proportional to the product of their masses. It means product of their masses, m into m, and inversely proportional to square of the distance between them, d square of the distance between them, d square, right? So let's go to the next one. This is what a universal law of gravitation, states. Okay, the force is along the line joining the centers of the two objects. What is the direction of the force? This force is not this direction. Okay, it is along the line. What is this line? This is the line joining the centers of the two objects. This you should be able to reproduce this in your exam. Okay. Now let's try to derive the equation. Okay, so that we use it in our day-to-day calculations, right? Let's take same as previous case. Let's take two bodies A, B, which has got masses m and m, which are separated by a distance d. Okay. Okay, let's take two objects A and B. Masses m and m. This mass is m and this is small m, right? Okay. Which they lie at a distance d from them. Center to center distance is like d. Okay, as shown in figure. Let the force of attraction between them is F. Let's call this the force of attraction between them as F. Okay, right. Let's see what happens. What the universal law of gravitation states? It states, okay, the force between the two objects is directly proportional to the product of their masses. It states the force between the two objects is directly proportional to the product of their masses. Then how do you write it? F is proportional to m into m, where m is they are the masses of two objects. Okay, and the universal law of gravitation also states that, okay, the force between the two objects is inversely proportional to the square of the distance, right? Square of the distance. So then how do you write it? F is inversely proportional to d square, or F is proportional to 1 by d square. We can say both the ways. Okay, F is proportional to 1 by d square, or F is inversely proportional to d square. Okay, now let's combine 9.1 and 9.2. Why I took 9 is this is a 9th chapter in CBSE syllabus. Okay, okay, now let's combine them. F is proportional to now product of masses here and square of distances here, combining them. Now how to get rid of this proportional symbol and replace it with equal symbol? Let's see that. Okay, let's put a constant, some constant. F is proportional to F is now proportional term is replaced with equal term. Okay, this equal term by adding a constant term. Okay, what is this constant term? G. Okay, G. So now F is equal to G into M into M by D square. Okay. Now what is called G now? G is a constant, of course, I said, right? And G is a constant of proportionality and is called the universal gravitation constant. Remember, G is a constant and it's a universal constant, a universal gravitation constant. Okay, F is equal to G into M into M and D square. So what is this constant's value? We'll see that in the next few minutes, right? And we can also derive this equation G. How do you derive it? So E is equal to cross multiply them, right? Cross multiply them. F into D square is equal to G into M into M, and G is equal to what? G is equal to F D square by M into M, and this is of course some constant number. We'll talk about it later, the exact number. Okay. Now, interesting stuff. What's happening? Look at it. The law of universal is the sense that it's applicable. What is the meaning of? See, we are calling this law as a universal law. It means this law is applicable at every place, at every conditions, right? So it is applicable for all bodies. It means big body or small body, doesn't matter. It's a solid or a liquid, doesn't matter, right? Okay. It's which place, celestial or terrestrial, on the earth or outside the earth, it doesn't matter. This law is applicable every under every conditions to every bodies. That's the reason we call this as a universal law of gravitation. Okay. And one more interesting stuff, to understand this is square, right? Observe this. This F is inversely proportional to square of the distance. It means if I double the distance, force will be reduced by 4 times. Okay. If I increase the distance by 6 times, if I increase the distance by 6 times, the force will be reduced by 36 times. So its effect is square, square effect. Now that we derived the formula for universal law of gravitation, right? Let's do some calculations and find the what is the force of attraction between two bodies. Okay, and see in the example, let's assume two bodies. Let's take two bodies. One is Earth, one is Moon. Okay, let's understand what is the force of attraction between Earth and the Moon. Okay, so what is given here? Observe this. Mass of the Earth is given. What is that? So the mass of the Earth is given. Okay, and the Moon's mass is also given. And if the distance between the Earth and the Moon is also given, okay, mass of the Earth is given, mass of the Moon is given, and the distance of between the Earth and Moon is also given. Then what we need to calculate, what is the force exerted by the Earth on the Moon? Remember, the force exerted by Earth on the Moon is equal to the force exerted by Moon on the Earth. But Moon moves, Earth doesn't move. Okay, let's understand what is the force now. Okay, and now it's given that the constant is given 6.7 into 10 to the power of minus 11 Newton meter square per kg square. Okay, it's given. Let's do the calculations now. And to solve, the 4 steps, right? List out what are the given values, then bring the formula, then substitute the given values into the formula and calculate. Okay, these are the 4 steps, remember them. Let's go one by one. Let's go for given values. Okay, what is the one? Mass of the Earth. What is the mass of the Earth? 6 into 10 to the power 24 kg. Look at the unit, it's in kgs. Okay, what is the mass of the Moon? It is equal to 7.4 into 10 to the power of 22 kg. Okay. And what is the distance between the Earth and the Moon? It is equal to, it's given here, right? 3.84 into 10 to the power of 5 kilometer. Okay, 3.4 unit. Look at the unit, kilometer. But the gravitational constant, right? What is the unit of gravitational constant in Newton meter square? So kg square, right? So kg is fine. Okay, but this is meter square, whereas this is kilometer. So I should have a same units across. Remember, let's convert this into the what? Meter. How do you do that? So kilometer is equal to 10 to the power of 3 meter, 1000 meters, right? 10 to the power of 3 meters. So then what is this? 10 to the power of 5 plus 10 to the power of 3. Sorry, 10 to the power of 5 into 10 to the power of 3. How much? 10 to the power of 5 into 10 to the power of 3 is 10 to the power of 5 plus 3. It's equal to 8, right? So now we'll talk about this formula sometime. But now 3.84 into 10 to the power of 8, 5 plus 3, remember, 8 meters. Okay, that's the distance. Now what is constant given? You know, this is a universal gravitational constant. Okay, gravitational constant how much? Is 6.7 into 10 to the power of minus 11 Newton meter square per kg square. Okay, now let's go for a formula. Okay, what is the formula? Talks about the gravitational force between two objects is given by Newton's law of universal gravitation. What is that? What is that? F is equal to G into M into M by T square. Now what is the next step? Substitute them. Substitute all these given values into this formula. Okay, now look at it. What is G? G is equal to 6.7 into 10 to the power of minus 11. Then what is capital M? Mass of the earth, 6 into 10 to the power of 24. What is this mass of the moon? 7.4 into 10 to the power of 22. Divided by square. Look at it. Divided by square of the distance. Okay, what is the distance? Distance is 3.84 into 10 to the power of 8. Let's solve this. Okay, right. Well, how do you do? Before solving it, let's separate out the numbers, separate out the decimal powers. Okay, that will be easy. Make less confusions while solving the problem, simplifying it. Right now, what I did was. What I did here is I took 6.7 separately, I took 6 separately, I took 7.4 separately, I took 3.84 square separately. Okay, it means 6.7 into 6 into 7.4 into 3.84 square. This entire thing is I took it separately, and remaining terms I'll put it separate, multiply separately. Okay, of course both has to be separate. Now what is this? 10 to the power of 11 here, 10 to the power of 11 here, minus 11, 10 to the power of minus 24 here, 10 to the power of minus plus 22 here, 10 to the power of 8 whole square here. Okay, remember. So now it has to be multiplied, remember. Okay, now life is simple now, while simplifying this very complex big numbers, right? Let's do it. Okay, let's see this formula. So of course a b c divided by d square, right? That's what. Substitute them. What is this? 6.7 into 6 into 7.4 divided by 3.84 square. Okay, you solve it. How do you do that? See, look at it. 297.48 divided by 14.7456. Remember, unless you have a calculator, it is a little bit difficult to divide this, right? You don't know the these are not divisible number, and you don't know that tables, right? So sometimes in this case either we need a calculator, or people are okay with adjusting with approximate numbers. Let's approximate. Can we approximate 297 as a 300? Can you approximate 14.7456 as 15? Now we know the 15, the table, right? That's equal to approximately, remember, it's equal to 20. Actual number is, remember, 20.17. This approximate number is good enough at this stage. Okay, 20, we got it. Now let's solve this remaining part also. Okay, what is before see, let's go with this number first. What is 10 to the power 8? What is 10 to the power of 8 whole square? Remember, in this case we multiply the powers. Okay, so 10 to the power of 8 whole square is equal to 10 to the power 8 into 2, which is equal to 10 to the power of 16. You should be able to recall from your previous classes. Okay, this property, okay, of the powers. Now let's go for other uh, 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 up numerator here, right? And all together. Okay, now what is this? 10 to the power of minus 11, 10 to the power of 24, 10 to the power of 22 divided by 10 to the power of 16. We got it from here. Okay, so now how do you do that? So now this is equal to, we can sum the numerator powers. Remember, when the base is same and they are multiplied, the numbers are multiplied, we can always sum the powers. In this case, 10 to the power minus 11 plus 24 plus 22, and this, because it's a new denominator, it goes up, it becomes a negative, right? It becomes minus 16. Now what is that? Just to make it up, see, 22 11 is easy to simplify. I wrote this. Okay, 22 minus 11 11, and 24 and 16 subtraction, 24 minus 16, it becomes 8. Total is 10 to the power of 19. Now put it them here. Okay, put this also here. Okay, Now that's equals to 20 into 10 to the power of 19. Maybe you can take one more number here. We can call it 2 into 10 to the power of 20. Okay. If you take exact number, it will be 2.017 okay, into 10 to the power of 20 newtons. Always remember the unit. Okay. Unit is a very important thing in physics, right? Okay. So what is the unit of force? It is newtons. Unit of force is, so this is very important. This is how we solved the problem. What is the solution? What is the force of attraction between Earth and the Moon? The force of attraction is equal to 2 into 10 to the power of 20 newtons. Okay. Okay. Now assessment. Okay. Okay. What is assessment? Again, these are important things which might appear for your exams. Okay. State the universal law of gravitation. And the other one is write the formula to find the magnitude of gravitational force. Just now we calculated between Earth and the object of this object on the surface of the Earth. Now we are, what is the force of attraction between Earth and some other object on the surface of the Earth? Let's do that. Let's solve them also now. Okay, state the first question. State the universal law of gravitation. What it says? I told you what it says. We already covered it in the just few minutes back, right? The universal law of gravitation. Of course, who gave that? Newton gave that. Okay. The universal law of gravitation states that what it says. Okay. Every object in the universe attracts what? Every object in the universe attracts every other object. What the universal law of gravitation says? Every law of gravitation, sorry, the universal law of gravitation states that every object in the universe attracts every other object with a force called gravitational force. Okay, it attracts. What is attracting force called? Gravitational force. Okay, the force acting between the two objects. Okay, the force acting between two objects is directly proportional to the product of their masses. Okay, is directly proportional to the product of their masses and inversely proportional to the square of the distance between them, between their centers. Okay, this first question is answered. Let's go for attempt to answer the second question, which is write the formula to find the magnitude. You need to write the formula to find the magnitude of the force, gravitational force, between what? Between Earth and some object on the surface of the Earth. Okay, let's do that. What is the formula? The formula for the magnitude of the gravitational force between the Earth and the object on the surface is given by, you know that, right? F is equal to G into M into D square. Okay, or we can also say M1 into M2 into by D square. That's the simplest way. Where what is F? F is the force of attraction between an object and the Earth. Okay. What is M? M is the mass of the object, because I'm using small, think of small object, okay, other than Earth. M is the mass of the object on the surface of the Earth. What is capital M? It's the mass of the Earth. Okay. Then what is this R? R is the, or you say D. Okay. D is the radius of the Earth. Okay, radius of the Earth, center, from the center you have to take it. Remember, okay, to the object. Okay. All right. Now we stated, we answered two questions. Now summarize this, subtopic of the gravitation. What are the importance of the universal law of gravitation? What are the importance? Let's see one by one. The universal law of gravitation successfully explained several phenomena which were believed to be unconnected long back. People were not knowing why planet revolves, why object moves, why one object is attracted to other object, why planets move around sun, why sun, moon moves around, right? So universal law of gravitation successfully explained several phenomena. Let's see what are those phenomena, right? The force that binds us to the earth. Why are we even, why are we not falling out of the earth? Remember, why are we falling? We are bound to the earth. So some force is, binding us to the earth. So that's what is explained by universal law of gravitation. And it also explained the motion of the moon around the earth. Why moon is, you know, orbiting the Earth. The third one, the motion of planets around the sun. See, all our planets, including Earth, rotates or revolves around the Earth. Why? This law provide an answer for it. And why tides happens in a moon? The tides due to the moon and the sun. Remember, so the tides will be very high during the full moon day and very why? Because it's full moon day. Earth, moon's attraction power will be very high. So tides will be very very high, right? These are the some of the few these are a couple of things which are you know a couple of phenomena which are very well explained by the universal law of gravitation. Before this, we were not knowing what's happening. Okay, this is the importance of universal law of gravitation. Now we covered topic one, right? Gravity and universal law of gravitation, right? In the next class or next video, let's talk about free fall and let's deep dive into it. Okay, thank you.